Good morning. Today we are going to study alkynes and alkadines. Main concentration definitely is on alkynes, and then we'll move to alkadines. Alkynes, as I told you yesterday, are sort of extension to alkenes in their chemical behavior. We are going to study mainly their chemical behavior. They also have similar type of pi bonds as the alkenes did. Okay, they also have similar pi bond, but the only thing is that in case of alkynes, the pi bond is RC triple bond CR, so it has two pi bonds. I am taking correspondingly alkadines also because they also have two pi bonds. Just simplest example could have been these two. I can have alene or I can have conjugated diene like these. So both of these have two pi bonds, and these two pi bonds when present make them reactive. Okay, presence of these two pi bonds make them reactive, as these two pi bonds are the loosely held electrons between the two nucleus of carbon. Correct? So in case of alkynes, what all reactions could be there, could be important. As I have taken intentionally a terminal alkyne, because terminal alkynes have slightly extra reactions or different characters as compared to normal alkynes. Non-terminal is the word I will use in place of normal alkynes. So these are the set of reactions that I would like to discuss with you today in this sequence of alkyne reactions. Okay, so let me just, as it is a terminal pi bond, let me just classify that these three reactions that are there are the acid base reactions given by terminal alkynes, as terminal alkynes behave acidic. Here, this is a cross, that is, it is a condition of no reaction that I'll discuss. Just give me some moments. After that, these are the reactions which are as like alkenes, normal pi bond reactions that we have already discussed in case of alkenes, just an extension. But these are the new set of reaction of alkynes that are important, and we will discuss them in our today's class. So without wasting any single second, let us start with their first set of reactions, that is acidic nature. Acidic nature, not of all alkynes, acidic nature of terminal alkynes. Terminal alkynes, this is important because all alkynes will not exhibit this nature. Excuse me. But this is a particular characteristic of terminal alkynes. Now, what we see is when terminal alkynes lose this H, then the anion formed is sp hybridized anion, which is with high percentage S character. Okay, it is with high percentage S character. So if it is having a high percentage S character, it is stabilized. It is relatively more stable as compared to usual carbon ions, and is therefore uh, relatively, please note, relatively to usual hydrocarbon alkenes and alkynes, make this terminal alkyne acidic. Okay, it is not that it has become acidic in random ways. Don't consider that now it is so acidic that it can it can displace inorganic acids and all. It is certainly not the case. It is nowhere close to such acids. Okay, it is certainly not close to such acids. Yes, it is acidic and can now behave as compared to other hydrocarbons relatively. Relatively, please underline the word relatively in your brain, as always acidity basicity should be referred in terms of relative context. Without the use of this word relatively, it is of no use. So, just to put my point in a little more clear perspective, that what I want to say, if I say pKa of ethyne, it is, some authors give 24, some gives 25, so it is in the range of 24 to 25. Okay, ethyne is 24 basically, and other terminal alkynes range from 24 to 25. So in general, I would like you to note that somewhere in the range of 24 to 25. If I go just to ethene, okay, if I move it to ethene, it is somewhere in the range of 49 to 50. It is somewhere in the range of 49 to 50. Now you can see the difference. Okay, you can see the difference, how terminal alkynes are much more acidic. Okay, are much more acidic than the normal, I would say, alkenes and alkanes. Okay, so what if it is acidic? What sort of reactions? As in our acid base chapter, we have discussed that such reactions are to be seen, are to be controlled, that how it will take place only with respect to the relative pK values. So let me tell you that if I take this and react it with sodium, always draw an equilibrium reaction and then you decide which side it will go. So RC triple bond CNA plus half H2 is liberated. Now this is my conjugate acid 1, this is my conjugate base 1 in the pair. In the pair, I can say. And for the similar comparisons, I would say this is my conjugate acid 2. Okay, this is my conjugate acid 2, which is basically the H plus donor if I take the backward reaction. And now you have to compare the acidic strength of conjugate acid 1 versus 2. Certainly, alkynes are much more acidic, are more acidic than hydrogen. So reaction always goes to weaker acid base side. So reaction moves forward. Okay, so whenever there is a condition like which side it will move, you have to go for the comparative acid base strength and then decide the direction of the particular reaction. Let me go to next. If I go to reaction with water. Okay, if I take this reaction with water, as you all know, I'll write a similar method, that this, okay, rather in place of water, I will take KOH. KOH, OH minus. So I'll write K plus, and here I'll write H2. So this is my conjugate acid 1, this is my conjugate acid 2. Correct. Now, water pKa is 15.6, 15.7. Correct. Whereas this pK, that is the alkyne, we have already said, let me take it 25. pK is 25. Okay. So again, you can conclude K of water greater than terminal alkyne. So reaction will definitely move backward. So my terminal alkynes cannot react like this with KOH. It is not a possibility. This is not going to happen, that my terminal alkyne can react like this. Is that okay till here? Now, what if I take RC triple bond CH plus any Grignard? Let me take, for example, CH3MgX. Taking similar considerations, methane will be formed, RC triple bond CMgX will be formed. Now, methane versus terminal alkyne is to be compared. We have already compared the alkane series, but to be specific, pK of methane is around 48 or further. This is 25. So again, as you can see, this reaction will move in the forward direction as methane is the weaker acid. Is that okay? Clear? Now, one very important reaction is reaction of terminal alkynes with NNH2. Please remember that terminal alkynes are more acidic than ammonia marginally. They have a close call, but certainly, ultimately, when comparisons are done, okay, when comparisons are done, it is more acidic. pK of ammonia is somewhere around 38, whereas pK of acetylene is 25. So it moves in the forward direction. This reaction happens. This reaction is feasible. Liberation of ammonia is observed. Okay, and don't get confused that ammonia had a something 4.75 and all those were kb beta. Okay, those were kb, and if you find ka plus kb equal to kw 9.2 or some value, then that is of ammonium ion, not of ammonia as an acid. Please think about that carefully without before getting confused in this data that I'm giving. The data for ammonia to behave as an acid, when I say it behaves as an acid, it means I want it to release NH2 minus and H plus. For that equilibrium, the pK is 38. So from here, I think all of you have been now clear that terminal alkynes have a special nature, that they are acidic. Okay, so this was our first set of 4 reactions that we have just completed, and from that I think by now you might have also understood why I have written cross over here. This reaction is not going to happen. Okay, why? I hope this is clear by now. So let us now move to electrophilic addition reactions of alkynes. Now move to electrophilic addition reactions of alkynes. In case of electrophilic addition reactions, what will happen? If I have any electrophile to be added, then certainly Rc positive double bond CHE or RCE double bond CH positive, two types of vinyl cations are possible. But both are ultimately going to be vinyl cations only. This way or that way, they are both going to be vinyl cations only. They are vinyl cations. Vinyl cations are unstable. Out of these two, yes, comparative, I would say that this one is major, this is minor. But still, they are not that stable as compared to the cations formed in electrophilic additions of alkenes. Okay, what we had in case of alkenes was far more stable as compared to these. So this is formed as major, this is formed as minor. Okay, but please take a note, but as vinyl cations are less stable than alkyl cations, therefore rate of electrophilic addition on alkenes is higher than that on alkynes. Please mark it as important that if you have one equivalent of any electrophile to be added and in the medium both alkene and alkynes are present, if I have this and this both present, iska one equivalent, and we are said that we have only one HBr equivalent where to add, then please add here. This will remain unreacted because the vinyl carbocation will require higher energy barrier, and higher energy barrier will certainly make it relatively more unstable. Okay, it will make it relatively unstable, thereby making the reaction less favorable, slower, preferable. So this is what the application of this green statement is, that given a choice, if you have a limiting reagent, if you have not enough reagent, then please add as per the requirement that alkenes will be added faster than alkynes. Is that okay? Clear? So what will be the effect of all these additions? What are the different reactions? These are the questions that have appeared in J. I'll come back to them a little later. Let us go through different reactions which are possible. So I'll start from here. First, reaction with dilute H2SO4. Reaction with dilute H2SO4 oblique HgSO4. It is known as Kuchrov's reaction. It is known as Kuchrov's reaction. Now let me first remind you that when it was alkenes and we had reaction with dilute H2SO4, then it was a reversible reaction in which Markovnikov addition of water took place. Okay, Markovnikov addition of water took place, and as a result, alcohols were formed. Okay, now if I proceed the same way for alkynes, simply that if I add dilute H2SO4H plus, then I will have very high barrier of the reaction as I have to go for vinyl carbocation, which is unstable. So, to decrease the barrier, we are adding Hg2 plus in the medium. Okay, this will function as catalyst. How will it function as catalyst? Now, this Hg2 plus will generate, okay, this Hg2 plus will generate a cyclic mercurinium ion. Again, we are having this cyclic non-classical carbocation for a third day in a row. Since Monday, we are continuously having this at least once in a whole class. This is cyclic mercurinium ion. Now, it is a non-classical carbocation. Mercury is not, carbon is not having a direct plus. Vinyl cation is not formed. Plus is on mercury, but the species still behaves like carbocation. Now water attacks on it. When water attacks, then our COH2 plus, it will attack, as we have discussed yesterday also, to the substituted site CH single plus. Okay, Hg single plus. Now it will lose R C OH plus will ultimately, let me write it like this, RCHOH double bond CH2. Hg2 plus is liberated. In demercuration, we reduce it to Hg. Here it is a catalyst. It is liberated as such. Now see, this is enol. It will immediately tautomerize to ketone. Okay. So what is the net product of this reaction? I'll write products are ketones. Okay. Only and only acetylene will form aldehyde. Otherwise, always ketones are formed in this reaction. Okay. Always ketones are formed, but only in the case of acetylene will we have the formation of aldehyde, acetaldehyde. Is that okay? Till here it is clear. Let us move to next reaction. One more point I would like to say that yesterday or day before yesterday we also had it, but repeating that yes, it is a Markovnikov addition, but and no free carbocation is formed. But when there is a benzene PHC triple bond CH and you do either OMDM or Kucherov, then the answers are PHCOCH3. As and as the stability of the carbocation involves become more and more stable, then a free carbocation could be formed. Okay, so don't go by the strict that it is going to be a Markovnikov, because you might think that pH is there, carbocation may come. Yes, if you go by a straight away Markovnikov that OH should be added to the carbon which is having less number of hydrogens, then you will do correctly. But if you'll go by the fact that no carbocation involved is here as it is a non-classical carbocation, then you might do error. So please note that as and as the stability of the carbocation becomes more and more stable, there is a possibility that a complete carbocation could be formed in such reactions also. To support this, let me show you this question which appeared in 2003 J. This question came in 2003. See, PHC triple bond C CH3. What we just did that in Kucherov reaction of this compound, you might think that CH3 is a plus I and pH is a minus I. So from where it should go? Okay, but the answer is PHCO CH2CH3, as the presence of pH will stabilize the cation here relatively more and more as compared to the plus I of CH3. So please be careful that don't go by just words, be spontaneous, take care of the mechanism, and then you proceed. Okay, there are certain reactions where direct answers may be valid, but there could be certain which may be confusing. So just be careful, nothing more than that. So this is how in HgSO4, H2SO4, we'll have addition of water, which is by Markovnikov, and then tautomerization will take place. Correct? Till here, I hope it is okay, but still I will take one more question of the type. If we are asked CH3 C triple bond CH, question is there, so no need to write the reversible. Just the fact that dilute H2SO4 plus HgSO4 is present. Okay, and here D2O is particularly mentioned in the reaction condition. So what should be the answer? Okay, so CH3CO CH3 option A, CH3CO CH D2 option B. If it is written prolonged, CD3COCD3, option C. Okay, CHD2COCHD2 as option D. Now answer is C. Why? Because once the ketone is formed, then through tautomerization, it will continue to exchange. I'll write just a hint that this type, tautomerization, it will continue to exchange this alpha H with deuterium. So please pay attention to the solvent given in the question, the language required. If prolonged word is not mentioned, then answer could be B also, because just immediate conversion and the answer goes to B. Okay. No further prolonged, then answer could be B also. So this was our Kucherov reaction. OMDM is similar. I cannot say OMDM is exactly same, but OMDM of uh, alkynes is quite similar to its Kucherov. And why can't I say same? Because as I think all of you must be aware that in this process, I just did when I um, removed that Hg as Hg2 plus in the end, right? But when it will be case of, OMDM reaction, it will be removed as rather mercury. So there will be slight differences, but yes, broadly I can say is quite similar. Correct? So let us write and discuss how this whole reaction could take place in case of alkynes. Okay. So again proceeding the same way, in case of alkynes, if I start R C triple bond CH, the reagent this time is HgOAc whole twice in water. Okay, and second I will have NaBH4 or not, that is unhold. We'll see. Okay, we'll see. If they give, then also it is very good. If they don't give, then also, but may or may not be. So come to this point. Answer is this. Let me start with its mechanism. Please remember that NaBH4 is not compulsory for alkynes. Okay, if H2SO4 is given, then also it is okay. NaBH4 given, तो it is okay. बहुत बढ़िया. नहीं दिए तो भी बहुत बढ़िया. कैसे और क्यों is the point. So, RC triple bond CH will react with HgOAc whole twice. We have done its mechanism. We have done how this will ionize and will form Hg single plus OAc. Okay, cyclic mercurinium ion is formed. Oxymercuration start हो चुका है. Water will now attack. Water when will attack will give me RCOH double bond CH HgOAc. Okay, it will form HgOAc. This is how it will be formed. Is that absolutely clear? Right? Now, as I formed this, due to, if I take H2SO4, I am writing if H2SO4 is given, this will react like this. RC double bond OH positive, single bond CH2. Okay, and HgOAc is there. This will be released. If this will be released, it will form RCO CH2 Hg OAC. Okay, this could be there. Now we have a ketone and we still have a Hg OAC here. Any weak nucleophile whichever can come can remove this HgOEC very easily. So if they give NaBH4, then you reduce by that. But then there is a problem. The reaction will not stop here. Reaction will go to alcohol. Correct? Reaction will go to alcohol. But in this case, here itself, okay, here itself, there is one more possibility. See if it goes like this. RCOH double bond CH2 is formed and Hg plus OAC is released. This can TOTO and answer is RCOCH3. So just by presence of H2SO4 you have ended the reaction to ketone. Ketone आया आराम से. Right. If I would have taken, just in case, if you take NaBH4, rather I should take care here also. If you take NaBH4, then answers are RCHOH-CH3. If you take H2SO4, then answers are ketone in OMDM of alkynes. Is that absolutely clear? If they give NaBH4, then answers will be alcohols. Is that absolutely clear? This is a relatively new concept for most of you, so please pay attention. In case of alkenes, NaBH4 is a compulsion that should be given. But in case of alkynes, you may have a condition where only HgOAC hold twice, and second step could be H2SO4 only. No need for NaBH4. Okay, is that absolutely clear? Now let us move to our next reaction. Oh, just a similar reaction, HBO, hydroboration oxidation. Now what will be there in HBO? Let me write triple bond CH. First is B2H6 in THF and second is NaOH plus H2O2. Here answers are aldehydes always. In case of OMDM, in case of Kucherov, always due to Markovnikov addition, ketones are formed. But in case of HBO, due to anti-Markovnikov addition of water, always aldehydes are formed. Okay, so here always aldehydes are the major product. Here aldehydes are the major product. Okay, because it is anti-Markovnikov addition of water followed by tautomerization. Pretty much like OMDM itself, but the difference is Markovnikov and anti-Markovnikov. Otherwise, it might look similar. Okay, so similar but still not similar. Is that okay? So once we have this aldehydes, mechanism is also same, that boron will be formed, boron and H will be attached, a very crowded transition state is formed, then attack of H2O2 plus NaOH formed anion and all those things. It is, yes, it is syn and all, everything is same. Okay, everything is same, Just a change is that it is alkyne. Nothing else. Nothing else. So, as it is a total repeat of our previous discussion, I would not invest much of your precious time into that. Let us move to next reaction. Does they give hydroxylation reactions? Hydroxylation reactions. What is hydroxylation reaction? For our importance, I'll write Bayer's reagent. Answer is yes. Okay. Alkynes also decolorize. Bayer's reagent. They do. Let us write one reaction. If I have this cold, dilute, alkaline KMnO4, then yes, first I will have such formation. It will undergo tautomerization and I will have this. Okay, now this alpha hydroxy is also very easy to oxidize. Will also change to this type of thing. Okay, ultimately I'll have 1 comma 2 diketo systems or alpha hydroxy. These two will be present in there. Correct. So they give decolorization of Bayer's reagent. Till here I hope you are okay. Now we are moving to addition of HX to alkynes. This is a little complicated to understand. I'll try my best to explain. RC triple bond Cr. If I add first molecule of HX by, if there is a possibility of Markovnikov, anti-Markovnikov, then answers will be Markovnikov. So I will have this vinyl halide formed by addition of one HX. Now what would happen if I add one more HX? If I add one more HX, then geminal or vicinal, what should be formed? Well, major is geminal, minor is vicinal, which some of you might be confused. Why and how? Let me explain. See, once a vinyl halide is formed and I want to add another mole of HX, and this HX is normally HCl, HBr and HI. As HF is very difficult to ionize and give this type of reaction. So it is HF, it is HCl, HBr and HI. Okay. So this HX now when added can form two carbocations. Let us have them here in a little elaborative form. I can have Rc plus X single bond CH2R when this is the site where H plus is added. See, this type of resonance will be there, na? Okay. But what if that this resonance is not used and I have this? So this is one possibility. Okay. Both of these carbocations are unstable, then RCH2CH plus R. They are both unstable. Both are unstable. Okay. So rate of addition of HX on vinyl halide will be lesser than normal alkenes. Answer is yes. Yes, because the carbocation formed is relatively unstable and it will be less possible, less rate-wise, slower reaction. Okay, so these things are there. But out of the two bad carbocations that I have in front of me for a choice, that is this, which is a little farther away from halogen. The benefit is I'm not having halogen come minus I, or I am having a lesser minus I as I'm comparing with this. Here, I have halogen attached immediately. Okay, so for both to compare, let me number them as 1 and 2. In 1, halogen is having its plus M or plus R and minus I tendency both. And certainly minus I is dominating over its plus R. That is there. Here halogen is showing only, minus I. No plus R is there. But yes, as the distance is increased, definitely the effect of its minus I is decreased, is down. Okay. So again, you might conclude then to this should be unstable, more unstable than the second one. Why we are preferring one? Let me give you some random numerical assumptions to help you understand. Assume, just assume that halogen, okay, halogen gives plus R or gives electrons or decrease the plus polarity on this carbocation by plus R. Okay, as it is poorer, I would say, assume karte ki it gives by say 80 units. And yes, it is closer, so its minus I is pulling electrons say by 100 units. Okay, see, minus I is dominating. It is pulling electron of 100 unit. It is donating or reversing the electron flow towards the carbocation by plus R 80 units. So net halogen is having electron withdrawal of 20 units. So yes, overall it is destabilizing. It is having an electron withdrawal nature dominating. So it is destabilizing our carbocation. Correct. Now here, as the distance is improved, assume due to increased distance, minus I will reduce. Okay. So let us say minus I say electron withdrawal is 70 units. So it has decreased in considerable amount. See here, just next it was withdrawing 100 units. In 1 and 2 bonds farther, it is withdrawing 70 units. But there is no plus R, 0 units. 0 units. So net halogen is having electron withdrawal of 70 units. I think this will help you understand that why relatively one will be preferred, one will be formed, and if one will be formed, thus one is more stable than 2. Okay, thus 1 is more stable than 2. And then if 1 is more stable, therefore gem dihalides are formed as final product, as major final products. Gem. Please mark this word gem. Please have a memory. If you can download these videos, keep them like a note. It will help you. Okay, in future also, if you are going to appear in exam next year, it will help you. So gem dihalides are formed here as a major final product because this carbocation is relatively less unstable Both are unstable, but less unstable as compared to this carbocation. Is that okay? So, in Markovnikov addition of HX to alkynes, we are having gem trihalides as final products. Now, what about the anti-Markovnikov additions? Okay, what about the anti-Markovnikov additions? Anti-Markovnikov additions. Yes, very true. Anti-Markovnikov addition of alkynes is observed. They are observed. Anti-Markovnikov addition of alkynes are also there. But the answers are vicinal dihalides. Okay, in their case, the answers are vicinal dihalides. Let me try again to explain. If I have this, I add first HBr H2O2 CH. I will have MECH double bond BRH. Correct? Now this Br. Okay, now the presence of this Br will have some effect on the further additions. Let me draw how it will have the effect on my further additions. If H C Br double bond C MEH. Next, Br dot is added. I'm not going into much of the detail of mechanism. We have discussed it yesterday. In case if anyone has problem, please refer to our Monday and Tuesday lectures for basic mechanism of all the reactions that we are covering here for alkynes. Okay. So now here, when this attacks, what happens is MEHBr. Okay. Here it is HBr dot is formed. Now this dot is basically, I can say to certain extent is stabilized by this type of cyclic bromine radical. Okay, here is the formation of cyclic bromine radical. Bromine radical. And then again by the use of HBr, we get MEC. I'm not going into much of stereo here. CH2Br. So we get somewhat like this. Okay, this is stabilized by this. But you have to remember, if it is a anti-Markovnikov additions, then answers are vicinal dihalides, and if they are simple Markovnikov polar additions, then answers are gem dihalides. Okay, till here I guess it is absolutely clear. Coming to what if instead of addition of HX, we are adding Br2 in CCl4 or chloroform. Then yes, by normal similar methods, Br2 in CCl4. First, when we add, we will have trans product because it is anti-addition. You add one more Br2, you will have tetrabromo. But as there is no chirality or GI, there is no difference. Till here you can see that it is an anti-addition. Okay, here it is not visible, though it will remain anti. And yes, in case of alkynes, the effect of this NT addition go considerably down. Okay, in case of alkynes, this NT addition thing goes considerably down. It is not that significant as it was in case of alkenes. Okay, as in case of alkenes, it was too significant that it has to be all cost NT addition. But in case of alkynes, let me have a experimental. In case of alkynes, NT stereoselectivity goes little down. To support my fact, I would like you to tell an experiment where this particular alkyne was subjected to reaction with bromine in CCl4. Okay, if it is very particular about trans, if I assume that it is very particular about trans, then I should have had this as a much major percentage. Like in case of 2-butene, it is almost 100% NT addition is observed. Okay, but as we go to alkynes, this type of selectivity towards NT addition is found to be much less. See the distribution of syn and NT. This will be formed by syn addition, which is almost 30% this time, and this is formed by trans NT addition, which is 70% formed this time. Okay, so this NT addition of halogen stereoselectivity in case of normal alkenes, say butene, propene, pentene, and all those cyclobutene and cyclohexene, is very high. Okay, even in styrene, it is very NT, almost 90 to 100% it is NT addition observed. But under two conditions, this NT selectivity is found to be lowered. One, when it is alkyne, and second, when similar observation is observed when it is PHCH double bond CHME. The carbocation becoming more and more stable. Then also this NT selectivity is found to go relatively less. Here also you have in case of styrene, again in case of styrene, it is also 70% NT, 30% syn is observed. The similar data is observed in case of styrene also. Okay, so here I thought that by this I'll be over with what should I say, the alkynes, but as I have some more alkynes, I'll use this later. So coming to further reactions of alkynes, our next reaction for alkynes is ozonolysis. 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 As far as ozonolysis is concerned, alkynes do show ozonolysis. First, ozone. Second, we'll have zinc plus H2O. Then by the same similar ozonide, molozonide formations, you may have 1, 2 diketones. Whenever zinc is written here, please give your answer as diketone. Okay, but if the question simply says ozone and second stage is water, then please give your answer as 2 moles of RCOH, as this will immediately go oxidation by H2O2. Okay, if H2O2 is allowed to be present, is allowed to survive in the reaction condition, then answers are no more 1, 2 diketones. Answers become 2 moles of carboxylic acids by this bond fission. Is it okay? Clear? So please carefully check what is given. Nothing more, nothing specific is there in this ozonolysis reaction. Okay, so I think we have completed all the basic repeat reactions till now for alkynes. There is other reactions like polymerization. In polymerization, I would like to have two reactions. When this is passed over a red hot iron tube, then benzene is formed. This is a cyclic polymerization. This is cyclic polymerization. Yes, it can be understood very easily that how this could have taken place. It does not involve any reagent or anything, just passed. See, it is a cycloaddition if you see. It is a cycloaddition and benzene is formed. Okay, 2 night 3. Okay, it should be 3. If you have 4 moles of acetylene, you will have cyclooctatetraene and similar things. Like if you would have propine, you can have mesitylene as answer. Possibility and so on. There is a possibility. Okay, these are its cyclic polymerization, but there is also a linear polymerization which is very important. Please pay attention. If you have 2 moles of acetylene, you pass it on Cu2Cl2 solution in presence of NH4Cl. You will have vinyl acetylene. Okay, you will have vinyl acetylene. Now on this vinyl acetylene, when this is done, this is close. Okay, vinyl acetylene is formed. The reaction I'll take in conjugated diene. What I was just about to take, I'll take after some time. So vinyl acetylene is formed. Please have this as a very important point. Okay. POC of terminal alkynes. I'm talking only terminal because rest is same as alkenes. They will give uh, bromine water decolorization. They will give Bayer's test. But these three are very different from normal alkynes and can be in fact used to differentiate them from other alkynes. I can differentiate a one ine from 2, 3, 4 other ines by this set of reactions. So what is the reaction? If I treat it with Cu single plus, we have red color copper alkylide. We call it copper alkylide is formed. Please mark it. These are explosives. They are to be handled very carefully and are red color precipitates. See, this is what is formed and then it attacks on next molecule of acetylene. The reaction proceeded similar. If you take it to Tollens reagent. Now see, Tollens reagent, you all remember, is ultimately AgNO3 in ammoniacal solution. In ammoniacal solution. It will certainly not give the usual Tollens test, that is appearance of silver mirror, but it will surely give again a grayish white precipitate of silver alkylide. So these two are tests. If the question says, please mark it carefully, if the question says that does alkyne give Tollens test, then you just say yes, it does. If it says does it give silver mirror, then you say no. Is that clear? Depending on the question, be very specific that does it give silver mirror test, then answer is no. But if it simply says that does it give a reaction with Tollens reagent and some test is there, then answer is yes. So mark this and please note the difference. Okay, let us move to some past JEE questions on bromine addition. Favorite of the JEE, I would say, is this bromine addition. It has appeared twice, thrice. Even in 2017, it was there. In 2018, there was a different reaction in comprehension. Here, I would like to discuss that X is the mixture. Okay, 2-butanol. Dehydration is done. Some X mixture is formed. What is this X mixture? Better, this X mixture is cis-alkene, trans-alkene, and 1-butene. Okay, if you remember, we did TAME and CART. Because bromine is anti-addition, they are asking bromine. 5 compounds of molecular formula. I think X was not an issue. You could all have done 3. But why 5 compounds? I want you to tell these 5 compounds. If this is added, bromine and CCl4, we'll have bromine and bromine. See, this is chiral. So 2 compounds here. Okay, trans-pent addition meso will be formed. So if when this is treated, then bromine, bromine, HHCH3CH3 meso is formed, only 1 will be counted. Correct? When this cis anti-racemic mixture, here you will have CH3, CH3, HBr, BRH, and the mirror image BRH, HBr, CH3, and CH3. So 2 products are here. So total, that is why the question says 5 products are formed. Okay, so X has to be 3 because without considering the formation of 1 enol, so you cannot explain 5 products. Okay. Now same thing, similar thing is again asked in 2007. See 2003, then 2007. The number of stereoisomers obtained by bromination of trans-2-butene. We just did trans-2-butene. Answer is meso only, so 1 is found. Okay. Similar thing, similar point again appeared in 2017. Again you see, this is trans. So M and N, a slight, I am finding it a slight less in font. So let us take help of, if there is a little zoom thing, it will help you to have a clear vision. So here it is meso formed. When it is trans, HBr, and yes, opposite side say B, if I take bromine H, but they are same now. If I say one is M, other is N, they are same. They are both meso. Meso's mirror image is superimposable. But here O and P will be enantious. Same concept you must be following, that it is asked so frequently. Okay. 2003, in between also similar things were asked, but different NOCl addition and other. So O and P are identical molecules. That is false because they are enantiomers. M and O and NP are 2 pair of diastereomers. Okay, M to O and N to P. Yes, certainly they are 2 pair of diastereomers. MO and NP are 2 pair of enantiomers. That is wrong because they are not enantiomers, they are not mirror images. Bromination proceeds through trans addition in both the reactions. That is true. So answer is B and D. These were some of the past questions on this concept. Okay. So now let us move to our conjugated diene thing. This. What would be there if we have this type of conjugated system? Well, if this type of conjugated system is there, then there are 2 type of additions which are possible. Okay, 2 type of additions which are possible. Now, what are those 2 types of additions. Correct? So let us see those. If I have CH2 double bond CH, single bond CH double bond CH2, coming back to our original size, okay, as we were. So we were discussing how our alkene will be formed. Give me a second. Let this system catch speed. So here we were. So if I add same way that H and nucleophile, this will act as an electrophile is added. There are two possibilities. I can have CH3, CH nucleophile, CH double bond CH2, or I can have CH3, CH double bond CH, CH2 nucleophile. 1, 2, 3, 4. Relative positioning is taken. This is called 1-2 addition, and this is called 1-4 addition. Okay, how it takes place? First, certainly any of the bond. Now, this is certainly the case when one equivalent is considered. First, when H plus will attack, I will have a stable possibility of carbocation as here. Okay, as it is allyl cation, it is resonating cation. This allyl cation is having resonance, na? CH2 plus CH double bond CH single bond CH3. As a result, this is existing as a hybrid CH CH3 as del plus and del plus. Okay, so 1, 2, 3, 4. If nucleophile attacks on 2, then CH2 double bond CH single bond CH NuCH3 is formed. Okay, if nucleophile attacks on 4, then CH2 nucleophile CH double bond CH single bond CH3 is formed. Okay, there are two possibilities, that this way or that way. Right? This is formed at lower temperatures like minus 60, minus 40, example. Then this is major. This is major at room temperature or higher. This becomes major. Why? Because this alkene is more stable. This is a thermodynamic product. When the product is more stable, then we call it thermodynamic product. Then this becomes stable due to the formation of more hyperconjugative alkenes. Correct? So please remember this. Yeah, a question in your brain may come that you have taken um, uh, unsubstituted type of diene. What if my diene is substituted like this? And now I am asked HNU to attack. And just to have a practice, I would suggest that instead of HNU, if I give you addition of HBr. Okay, so my first carbocation choice are also now of two types. I can have this as a carbocation, or I can have This is a carbocation. Which do you think is more stable? Both are allyl resonating, but this is more stable as it is having 3 degree. So this is going to be minor. So in them also, if you have a choice, then select the one which is major. So now on this Br minus will attack, bromine goes here. Because if you'll go by this, your answer would be, which is wrong. For single correct, you have to select this one. So out of those two conjugated pi bond also, if you have a choice, then take the attack at more stable carbocationic site. That is the rule in general for all electrophilic addition reactions. Okay. If there were two pi bond in conjugation, you have taken. But if my structure is CH2, C triple bond CH, and I'm given one equivalent HCl. See, non-conjugated. Oops, I took both as CH double bond CH2. So then you will add on CHCl CH3. All these are very important examples. Please take care. Okay, because the electrophilic addition on alkene is faster. But if this triple bond is in conjugation with double bond, if is in conjugation with double bond and same one equivalent of HCl is given. If you remember, I have just formed vinyl acetylene some 10 minutes ago from acetylene by the use of Cu2Cl2 and NH4Cl. Then reasons I don't have time and you don't need, but remember then the attack is on triple bond. And this particular compound formed is very important. It is chloroprene. Okay, this chloroprene when polymerizes, then it form a very important neoprene rubber, synthetic rubber. Yesterday I told you isoprene, 2-methyl 1,3-butadiene. It formed natural rubber. 2-chloro-1,3-butadiene is chloroprene. It forms synthetic rubber. So please remember these points. Okay, when to attack where. And one more important point, allenes CH2 double bond C double bond CH2. If this is said to add one equivalent of HCl, you might want to do this. Okay, but please mind this is major, this is minor. Okay, this is major, not that one. Okay, explanation is beyond our syllabus and level, but it is a very important point. In case of allenes, it is not the allyl site which is attacked. Actually, during the formation of carbocation, when it is being formed, okay, when this bond is just broken, del plus is just being acquired, then this is not resonating. This transition state is unstable. Whereas when we have this del plus is coming over here, okay, when we have a del plus coming over here and H is attacked here, then this is unstable, then this. And so answers are addition to middle site. Okay. Let us conclude the different reactions of conjugated dienes CH2 double bond CH. single bond CH double bond CH2. If we are given bromine and CCl4, one equivalent always, huh? Then please be very clear. Observation is formation of trans. I'm only talking about the major products. 1,4 addition and formation of this type of trans isomer is clearly observed. This is too high in concentration. Okay, this we have already done. Here also major is trans. Okay, but certainly to a much larger extent, this is also formed as larger as compared to bromine addition. It is way too much trans. Okay, when we do ozonolysis followed by zinc and water, then we have 2 moles of formaldehyde and 1 mole of glyoxal. Okay, when you have 1 equivalent of hydrogen on nickel, then again you will have this as a product. Here it is, major is cis. Clear? So this was the addition of conjugated dienes. This was a 2012 question. Let me tell you something about this one, that how it was done. The number of optically active products obtained on from the complete ozonolysis of this. See, ozonolysis done here, here, and here. So CH3CHO plus CH3 CHO and CHO. It is no more chiral. Second unit CHOCH CH3 CHO plus CH3CHO. So as the two groups are now same on both the sides, these two chiral centers which were chiral otherwise are no more chiral. Okay, are no more chiral, and thus as a result of this whole thing, the overall answer, okay, is 0 because none of the product formed is chiral. Is it okay? One more question I would like to deal is 2006 CH3 CH double bond CH2 plus NOCl. This was 2006 J question and product was P. Identify the product. I want you to tell that for all electrophilic addition, you just need to understand how this will split. This is nitrosyl chloride. You can have it as NO plus and Cl minus. Though the mechanism is through cyclic nitrosonium ion, but then the addition is NT and Markovnikov. So answers are CH3, CHCl, CH2NO. Is it okay? Clear? So this is how we have tried to cover as many as possible important aspects of alkyne and diene chemistry. Please study the notes of your classes, your class notes. Go through this lecture, revise it, and then solve the past year questions. I would strongly suggest for you to download the actual question papers from IIT sites, not from any usual book which is available in the market for the past 10 years, past 20 years, past 40-year questions. They might or might not be relevant. Just go from 2007 to 2018 question papers which are available on IIT Mumbai sites or any IIT Mumbai, Delhi, Chennai, any site it is available. Please download the papers and the answers because they give the actual key changes also if ever they were done. For elimination, I also suggest you to solve the comprehension of last 2 years, 2018 and 19 JE papers, which was very important. Okay, go through all these things that will close us, that will bring us to the closure of hydrocarbon topic of open chain, like alkanes, alkenes, and alkynes. Next 2 days of our week, that is Thursday and Friday, we'll study benzene and its chemistry. So see you tomorrow with benzene, its preparation and properties, aromatic nature, aromaticity. Very interesting topic, I must say. So see you tomorrow at 10 a.m. Till then, take care, keep working hard, stay safe.